Okay, Wildcats, today we're going to the cats of the back generating algebraic expressions. Okay, student works 1 and 2 of the warm-up. Okay, so go ahead and do that. All right, now let's take a look at the next page. Getting started, blast from the very recent past. Miriam owns a flooring company. Her latest job involves tiling a square room in a pattern of alternating black, white, and gray tiles as shown. Consider scenarios from the previous lesson. Describe the growth pattern for each scenario. Miriam Flooring Company. The total number of tiles grows at 2 times the design number minus 1 squared. So the equation is T equals parentheses 2D minus 1 squared. Okay, secret ballots. The class president, vice president, and treasurer of a high school count the ballots for the homecoming king election. The day after the ballots counting, each ballot counter tells 2 of their friends in the senior class the election results. The following day, each of the ballot counts or friends share the election results with 2 of their friends in the senior class. The pattern continues for the entire week leading up to the pep rally. The number of seniors who know doubles each day. When we talk about doubles, we're really talking about exponential. So we're going to go to Desmos, graphing calculator. We're looking for statistics linear regression. Even though we don't want linear regression, the only option Desmos offers is statistics linear regression. So we're going to go open graph, but we can change the linear equation to exponential. To do that, that's a times parentheses b to the x to the 1. Now our regression is exponential. So now all we need to do is change the table. So we have okay, so we've added data. You can see here that the graph matches the points. The r squared is 1 means it's a perfect match. So our equation is s equals 1.5 times 2 to the d. Okay, so now let's take a look at backyard. Miriam and Matthew are designing their backyard patios. There will be an entrance and an exit off the front and back of the patio. The sequence shown represents the different designs depending on the size of the patio. Okay, so let's go ahead and make a table based on this. So design 1 has 1, 2, 3, 4, 5 tiles. Design 2 has 4, 8, 9, 10 tiles. And design 3 has 5, 10, 15, 16, 17 tiles. Okay. Now, this appears to be quadratic, so we're going to go back to Desmos. And it's better to start a brand new regression, so go to Desmos, graphing calculator. Now, even though we want quadratic, we still have to pick statistics linear regression. And we're going to change linear to quadratic. So ax1 squared plus bx1 plus c. So now our regression is quadratic. Now we just need to change the table values. So 1, 2, 3, 5, 10, 17. Now you can see here that the graph matches the points. The r squared is 1, so it means a perfect match. So our equation is t equals 1d squared plus 2d plus 2. So our equation is 1d squared plus 2d plus 2. Where they use x, we're changing x to d because that's the variable we're using. All right? So t equals d squared plus 2d plus 2. Now, I'm actually going to move this right here. So that way there's no confusion which equation goes with which. So this goes with Marion flooring, this goes with secret ballast, and this goes with backyard. All right. Number 2, describe how the quantities change relative to one another. For each scenario given, positive quantities, as each independent quantity increases, the dependent quantity increases. All right, let's take a look at the next page. Activity 2.1, using patterns to build expressions. Miriam's flooring business is booming. She decides to hire several employees to help lay out her tile designs. It will be necessary for Miriam to describe her tile designs in clear manner so that all of the employees can create them correctly. Miriam's square floor designs uses alternating black, white, and gray tiles. Describe the pattern of new tiles that are added to each design. The pattern, linear, quadratic, or exponential. Explain your reasoning. Now, we're going to come back to number 1. We're going to do number 2 to help us answer number 1. So we have our table. We know that in 2 it says write an expression to represent the number of new tiles that must be added to the floor design to build the next design. Let T represent the number of tiles along the edge of the square. So number 1 has 0. Okay. Number 2 has 8, and number 3 has 16. Okay. So now let's use this, and let's use our regression. So I'm actually going to open up 3 Desmos tabs because we need to do linear, quadratic, and exponential. Okay, so let's do linear first. Graphing calculator. Statistics linear regression. Now in this case we want it to say linear, so we keep it as the linear equation, and we just change the table. So that's 1, 2, 3, 0, 8, 16. Now the equation goes through the points. The r squared value is 1, so it means it's a perfect match. So we're saying this is a linear equation, but let's double check the quadratic and exponential just to make sure. Okay, so let's repeat this. So then we go to graphing calculator, statistics, linear regression. Now we want to change the linear to quadratic, so ax1 squared plus bx1 plus c. Okay, again, we change the values. So 1, 2, 3, 0, 8, 16. Now, the points look like they go through, and it says it's a perfect match, but here's the thing. A is 0, so this goes away. So this is basically saying it's a linear regression, okay? So far, we're saying it's a linear regression. Let's check exponential. So statistics, linear regression, open graph. Now we want to change this to exponential. Okay, and so let's change the points. So then that's 1, 2, 3, 0, 8, 16. You can see that it doesn't go through the points. The r squared value is not 1, so it's not an exact match. So then linear was a perfect match, and quadratic was a perfect match, but there's a little thing about quadratic we'll show you in a second. So let's write the equations down. So let's write down this one first. So this would be 8d minus 8. So 8d minus 8. Okay. But let's go ahead and write down the quadratic one. That would be 0d squared plus 8d minus 8. So, wait a second. It says quadratic, but 0d squared goes away, and you're left with 8d minus 8, which is linear. Okay, so the number of new tiles in each new square floor design increases by 8 each time. The pattern is linear because the pattern is increasing by a constant. All right, go ahead and finish writing that down. All right, let's take a look at 3. Describe which values for t make sense in this, where t is the number of tiles in this problem situation. Positive values for t make sense because you cannot have negative number of tiles. All right, let's take a look at the next page. All right, we're going to skip 4, and let's take a look at 5. Miriam asked her employees to determine the number of new tiles added to Design 2 to create Design 3. Each employee described a unique method to determine the number of additional tiles needed to create Design 3. Represent each of the employees' explanations with an algebraic expression that describes how many new tiles must be added to an n by n squared to build the next design. Now, everywhere we see a 3, we're going to substitute n. I must add n tiles to each of the 4 sides of the white square, which is 4 times n. Then I must add 1 tile at each corner, so the number of additional tiles added to the Design 2 square floor design is 4n plus 4. So the expression is 4n plus 4. All right, go ahead and finish up Bulma. Now let's take a look at the next page. All right, Howard. I must add 5 tiles to 2 of the sides and n tiles to the other 2 sides. The number of additional tiles added to Design 2 square floor design is 2, parentheses, n plus 2 plus 2 times n. So Howard's expression is 2 times n plus 2 plus 2n. All right. Student works Tyler and Tamara's expressions. All right. Once you've worked those, you'll see that which expression do you think Miriam should use? Explain your reasoning. Miriam should use Wilmot's method because it requires the fewest calculations. All right, let's take a look at the next page. All right, we're going to skip 7, and let's take a look at 8. Use each expression you determined in question 5 to calculate the number of tiles that must be added to squares with side lengths of 135 tiles to create the next design. So we're going to plug 135 in for n. So that's 4 times 135 plus 4 equals 2 times 135 plus 2 plus 2 times 135. And then that's 135 plus 135 plus 135 plus 135 plus 4 equals, and then that's 135 plus 2 squared minus 135 squared. Okay. Now, we don't need the regression Desmos anymore, so let's get rid of those. And then let's come here. Let's go to Desmos. And then we're going to go to Scientific Calculator, and let's plug each of these in. So 4 times 135 plus 4. 2 times 135 plus 2 plus 2 times 135, and then 135 plus 135 plus 135 plus 135 plus 4, and then 135 plus 2 squared minus 135 squared. Well, you'll see here that they all equal 544. Okay, so this equals 544. This equals 544. This equals 544. And this equals 544. All right, go ahead and finish it up. All right, let's take a look at the next page. All right. Let's skip number 9. Let's take a look at number 10. Use algebraic properties to show that Wilma, Howard, Tyler, and Tamara's expressions are equivalent. Justify your reasoning. Well, Wilma's is 4n plus 4. Let's simplify Howard. So that's 2n plus 4 plus 2n. Tyler's 1, 2, 3, 4n plus 4. So we can see that Tyler and Wilma's are equivalent. Now let's look at Tamara. So that's n plus 2 times n plus 2 minus n squared. Well, Wilma's still 4n plus 4. 2n plus 2n is 4n plus 4. 4n plus 4. So we see that Wilma, Howard, Tyler's are all equivalent. So n times n is n squared. N times 2 is plus 2n. 2 times n is plus 2n. 2 times 2 is plus 4 minus n squared. Well, n squared minus n squared cancels. You get 2n plus 2n is 4n plus 4. So Wilma's is 4n plus 4. Howard's is 4n plus 4. Tyler's is 4n plus 4. And Tamara's is 4n plus 4. So they are all equivalent. All right, go ahead and finish that up. All right, let's take a look at the next page. All right, the student is going to work 1A and 1B. And once you've worked that, you can work 2. All right, and then the students will work 3, 4, 5, and 6. So the student's going to work number 3, numbers 4 and 5, and 6. All right, go ahead and finish up the work in the book and have a wonderful Wildcat day.